Paul introduced the Haversine equations in Lesson 13. Given the latitude and longitude of 2 points on the Earth, the Haversine equations will calculate the actual, not straight line, distance between those points and the initial heading from the first one to the second. Our assignment in Lesson 13 was to key in these fairly complicated equations and verify that they're working properly before inserting them into our GPS tracker code. In Lesson 12, I walked from my driveway to a local historic church, collecting lat and lon data in a PicoW file as I went. For Lesson 13, I input that data into Google Earth, then used the ruler tool to evaluate the distance and initial heading between my driveway and the church. Google reported the distance as 263.75 meters with an initial heading of 62.9 degrees. Let's compare our MicroPython calculations to Google Earth's calculations. This is a trig-heavy program, so we start by importing math. Next, we declare some variables. Earth radius is self-explanatory. Google distance and Google heading are the results we got from the Google Earth ruler tool. Given the latitude and longitude of 2 points, the Haversine distance and heading function will return the actual distance and heading between them. The function starts by converting the provided decimal degree latitude and longitude values into radians. Paul provided the main equations shown on lines 17 to 21. The Haversine distance and Haversine heading are returned to the calling routine on line 23. The main part of the program starts with opening the Lesson 12 CSV data file and reading the first 3 lines. The first line in the file is driveway data. Control characters are stripped off, and the line is split on comma characters before assigning it to the driveway list variable. Note that driveway element 2 holds latitude data, and driveway element 3 holds longitude data. The second line of the file is discarded because it was recorded en route between the driveway and the church and has no value in this assignment. The third line of the data file is read in as the church list variable. It is managed like the driveway variable. Note that church element 2 holds latitude data and church element 3 holds longitude data. Line 31 calls the Haversine distance and heading function, providing the lat and lon data of the driveway and church endpoint. Lines 33 to 35 print a comparison between our Haversine results and the Google Earth result. Here we can see an acceptable difference between our Haversine equation results and the Google Earth results. I'm confident we can transfer the Haversine equations to our main GPS program. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.